Hi everyone, this is Janine Co, aka Janine the Tutor. As you all know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt quickly. And because we want to extend our helping hand to you, students, we are running daily classes and they're free for math and chemistry from grades 11 to first year college and university. In addition, we are also offering 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, we are going over Algebra 2. So I'm starting from Chapter 1 and going towards the end. So if you do have any questions, please let me know. I just want to make sure, can everyone see my screen so far? Can I get a yes if you guys can see my screen? For the people who are coming in on YouTube and Facebook? And am I coming through clearly? Can I get a yes as well? I'm also curious to know where you guys are coming from, like where are you currently based right now? So please make sure to drop that down below. Okay, so through these questions, so we're starting from the easiest questions and then we're working our way through. So we have to simplify the expressions. So there's five of them. And as you can see, we have 7x squared plus 3y squared minus 2y squared minus 4x, right? So based from what you've learned in class, right? So just to make sure you can see my pen as well, right? Moving around. Okay, so we have 7x squared, and we also have minus 4x right here. So as you can see, they're the same variables, but they're not like terms, right? So first of all, what's a like term? So a like term would have to have the same variable, and they need to be raised in the same exponent. So for example, if you're looking at 7x squared and minus 4x, they're not the same variable. Therefore, sorry, they're the same variable, which is x, but they're not raised to the same exponent because this one is raised to the power of 2, and this is raised to the power of 1. Therefore, they're not like terms. Does that make sense? However, if you see 3y squared and minus 2y, right, these two are like terms. And why? Because both of them have y squared. So that means I will be grouping them based on like terms. Okay, so we can simplify this. So we have 3y squared minus 2y squared. So all you have to do is subtract, right? So you're going to get y squared, and that's positive y squared. So you're going to have 7x squared, and this would be plus y squared. This is minus 4x. So when you simplify this expression, this is how it should look like. Just so you know, this is minus 2y squared. Just wanted to point that out. Okay, so moving on to question 2, right? As you can see, you have terms that are within a parenthesis, right? So you have a -1 here, right? Which we typically don't write. So you need to distribute this individually to each of the terms, right? And when I say term, that means it's this term, this term, this term, and this term. Does that make sense? So a coefficient, which is 3, and a variable, that's one term, right? And then m is another term because it's not the same term as 3k. Does that make sense? And then if you're looking at k right here, this is another term, right? Minus 4m is also another term, so you need to distribute that individually. Okay, so that means in this case, when you simplify this, you would have negative 3k, right, minus m. And how is it minus m? Well, negative 1, right, because you have a negative 1 here. It's just that we don't write this in algebra because this is just for simplicity, right? So negative 1 times 3 would be negative 3k, and then you have negative 1 times positive 1m, right? Again, there should be a 1 here. That's why 1 times m is going to be itself, right? That's why it becomes negative, right? Because a negative number times a positive number is negative. And then you have plus 2k, right? Positive 2 times positive 1, right? K, so you're going to have k. And then you have minus 4. So 2 times negative 4 is negative 8m. Does that make sense, everyone? This should be negative 8. Okay, so when you simplify this, I'm just going to box this so we know. So this is the first one. When you simplify this, you're going to see that this negative 3 and 2k, they're like terms, right? Because they have a coefficient and then you have the same k, right? Variable, and you have the same exponent, therefore you have the same power. So power just means you have your variable and it's raised to an exponent. That's what you call power. And then you have minus m and you have negative 8m, right? So this negative 8m, right? These two are like terms, right? As I've indicated. And then you can go ahead and combine this. So you're going to have negative k because it's negative 3k plus 2k. That would give you negative k. And then you have negative m, right? And negative 8m, that would give you minus 9m. Because what happens here is you're subtracting 3 and 2. You're carrying over the negative sign because the negative sign is found in the larger number. And as a result, you get negative k. On the other hand, you have negative m and negative 8m. I like to remember things by adding them, and then I'm just carrying over the negative 9 because the negative sign is like dominant, right? So that's why it's negative 9m. Okay, moving forward. So that's your simplified expression. Moving to this, we have negative 4j squared and j squared. These two are like terms, therefore we can just combine the two and have negative 3j squared, right? Because negative 4 plus 3 is negative 4 plus 1, right? This is a 1 right here. That's going to be negative 3j squared. And then you have 7k, but it's negative, right? Negative 7k and plus 5j. Well, these two are not really like terms, so you can't really combine them further. So you have negative 7k plus 5j. So that's your simplified expression. Okay, how is everyone doing so far? Just wanted to make sure everyone is following. For the people who are tuning in, you guys are following? Can I get a yes? Okay, sounds good. So for number 4, right? This is very similar to number 2 because you're applying the distributive property. So in that case, you're going to have to distribute the negative sign here. So this is going to be negative 8a, right? And this would be minus 3b, right? So you need to expand this further and then you combine the like terms. So that's how you're going to solve it. Minus 8a minus 3b, right? Negative 1 times positive 3b, that's negative 3b. And because you have a 10 in front, you're going to multiply 10 times 2, right? So 10 times 2 is 20, so that's plus 20a. And then from there, you're going to see that this is 10 times negative 5, so that's negative 50b. Does that make sense, guys? And then you're going to see you have like terms, which is negative 8a and 20a, right? And then you have this and you have this, right? Because they're both b's. Therefore, simplifying this, you're going to have, negative 3b, right? And negative 50b, which is negative 53b. Okay, and then you have 20 minus 8, which is 12, right? 12a. So 12a and negative 53b. There we go. Okay, so moving on to number 5, you're going to apply the distributive property here because you have the parentheses. So you have 3 times 2x, which is 6x, and then you're going to have minus 3, right? And on top of that, because you have a negative 2 here, you're going to have minus 6x. Does that make sense? Because negative 2 times positive 3 would give you negative 6. And then you have negative 2 times the constant 4, which is positive 4, right? That would give you negative 8. And that's going to be equal to 11x, right? Does that make sense? So as you can see, because you're looking on your left-hand side of your equation versus the right-hand side, you're seeing that you have 6x minus 6x, so you can cancel this out, right? Because it's equal to 0. And then you can add negative 3 and negative 8 together, so you would get negative 11, right? Which is equal to 11x. And that's going to be divided by 11, right? Because you want to isolate x. So you're going to see that x is equal to negative 1. Does that make sense? Okay, so that's your final answer. So moving on to question 6 to 10. So here is an interesting way to ask this. Is the equation always, sometimes, or never true? So, okay, I don't think we're going to have enough space. So let me just copy this and then we're going to move it down because I want to have enough space. Okay, can you guys see this? There we go. Okay, so this is from number 6. I just realized we won't have enough space, so I'm just going to write this here. Okay, so this is from number 6 from above, right? So all of the solutions from 6 to 10 will be below. So first of all, how do you know if this is always true, sometimes, or never true, right? So maybe we can combine the like terms and then see what we're going to get. So in this case, you have 6 and negative 2x, so that would be 4x, right? And you have plus 5 on this left side of your equation, and that's going to be equal to 4x, which is plus 5, right? So as you can see, when you try to subtract this 4x from this 4x, right? Because when you move the 4x to the opposite side of the equation, or if you move this to the opposite side of the equation, you're going to get 0 eventually, right? So we can just cancel this out. And then you're going to see that 5 is equal to 5. And let me just stop and just quickly ask you, is 5 is equal to 5 always? Yes, right? So that's why this is always true. So that's how you answer these types of questions. Okay, so moving on to number 7. Again, we're going to copy this and then you're going to see the solutions at the bottom. So by the way, a friendly reminder, all of my sessions or daily sessions, including this one, will be recorded, so you don't have to necessarily keep on writing things down, because at the end of the day, I want to make sure you understand what I'm presenting. Like, I would rather you attend my class after that and finish this class, and after that understand everything that I've just presented, as opposed to you writing things down and you not understanding. So yeah, just wanted to point that out. Okay, so you have 2x minus 7 plus 3x is equal to 4x plus 8 minus 12. So as you can see, you have 2x and 3x here, so that would give you 5x, right? Minus 7, which is going to be equal to... Okay, for some reason. Okay, there we go. Yeah, I just want to make sure that this is aligned with the equal sign. Okay, so 5x minus 7, and that's equal to 4x, and then we have minus 4, right? 8 minus 12 is negative 4. So 5x minus 4x is equal to x, and then you're going to have to move the negative 7 to the opposite side of the equation, so you get 7 minus 4, which is 3, right? So here's the thing, because this is a variable, right? This could be any number. So this could be 3, which is always true if it is. But it could also be 2, it could also be any number because it's a variable, right? That's what variables do. So that means this is sometimes true. Okay, hopefully that was pretty straightforward. Nothing really crazy to stress about. And let's proceed to number 8. Oh, apparently it's until question 11. So question 11. Okay, there we go. Okay, so let's try to group the like terms. We have 6x and negative 3x, so that would give us 3x plus 5. And on the left side, you have 3x, and this is 11 minus 7, which is going to be equal to 4, positive 4. So as a result, you can see that you can cancel the 3x out. And why is that? Because if you move 3x to the opposite side of the equation and vice versa, you're going to get 0. So as you can see, you're going to have 4 is equal to 5, right? So this is never true because you can't have this equation. Okay. So moving on to number 9, we have an inequality. So interestingly, a lot of students, they struggle with inequality, but don't worry, it's not too bad. It's actually pretty easy if you actually understand it. So if you have 5 times 2x minus 3, right, distributive property, you're going to have 10x minus 15 minus 7x, and that's going to be less than or equal to 3x plus 8. Okay, hopefully that wasn't too hard. And that's very similar to what we've been doing with equations, right? So as you can see, we have like terms. So we have negative 7x, we have 3x. Okay, we can deal with the 3x later on. And then we have 10x, right? So 3x is over here, 10 minus 7, 10x minus 7x, that's equal to 3x. And you have negative 15, and you have 3x, and this is plus 8, right? You guys following? Okay, so 10x minus 7x, that would give us 3x. And then you have 3x right here. And then you have negative 15, and you have positive 8. So that's right here. So when you move the 3x to the opposite side of the equation, because remember, when you're moving any number to the opposite side of the equation, you have to switch the signs, right? So you have to switch it to its opposite sign. So right now it's positive. If you move this, it would become negative. So that would cancel out 3x and 3x, right? And as you can see, if you have negative 15 less than or equal to 8, right? Can you say that 8 is greater than negative 15, right? And is it equal to? Okay, so in that case, right? And also, because if you're looking at this question right here, even though that we're dealing with inequalities now, you have to make sure, let's see. Yeah, you have to make sure that you have canceled out all of your x's because sometimes inequalities require you to draw graphs, right? But we're going to get to that in a bit. But I just wanted to point that out right now. Yeah, it's one of the questions here. Solve and graph of the following and graph the following inequalities. So it's right here. So yeah, sometimes if you do have a variable, you need to graph your inequality, right? So but in this case, if you have which is less than 3x plus 8, can you say that 8 is going to be greater than negative 15? Yes, right? But it's not always equal to. So this is just sometimes true. Does that make sense, guys? Okay, let me just take a look at the other questions. Actually, let me finish the 10 and 11. Okay, so for number 10, that means you have 9. Okay, this is sometimes true. I forgot to write that. Because you can't have that equal to negative 15. That's the reason. Okay, so if you look at number 10, basically you have 9x, right? And this is plus 4. So I'm looking at number 10. And I'm distributing 2 times 2, which is 4. And that's going to be plus 2x. And that's less than 5 plus 9x, right? So the 9x right here, and you have a 9x right here. Actually, you do have a 2x here, so that would be 9x plus 2x, right? So 9x plus 2x would be 11x, right? Okay, so 9x plus 2x is going to be 11x, and then basically, sorry, actually, let's go back to number 9. I just realized something. So okay, so if you have a variable, whether it be an equal sign right here, so for number 7, right? You have a variable and then we're saying this is equal to 3. This will also be considered as this will be considered as sometimes true, right? And the reason for that is because this variable could be 3 sometimes, and it could be any variable, right? But the thing here is, if you look at number 9, right, they're saying that it's negative 15 and this is less than or equal to 8. So they're not giving you a variable. That's why you can never say that it's sometimes true, because definitely it's negative 15 less than or equal to 8. And that's not true, because you cannot say that negative 15 is equal to 8. So that's never true. Okay. Hold on. So now let's go back to number 10. So we have 9x plus 2x, that's 11x. And then basically you have 9x on this side, right? So we can just move the 9x to the opposite side. Okay, 11x minus 9x from here, that's going to be 2x. And this is going to be less than, and then you have 5 minus 4, right? Which is 1. So divided by 2, right? So because you have x and this is less than 1/2, right? You can actually say that this is sometimes true, right? Because remember, if it's a variable, it could be 1/2, it could be any number that is less than 1/2, right? So this could be sometimes true. So that's how you go about this question. Okay, so number 11, I think that was the last question. Yeah. Okay, so for number 11, again, you're going to apply the distributive property. If you have negative 2 times 3x, this is going to be negative 6x minus 2, and that's greater than negative 6x plus 7, right? So as you can see, basically you have negative 6x and then you have a negative 6x here. So when you move the negative 6x to the opposite side of the equation, you're going to get positive 6x, right? So this is going to be 0, right? Yeah, because you can cancel out, right? And then this is negative 2, which is greater than 7, right? So can you say that negative 2 is greater than 7? No, right? So that's why this is never true. Okay, cool. I think I went through until 11 now. Do you guys have any clarifications so far? Sorry, did you want me to clarify anything? Okay, there we go. This is just number 11. Okay, cool. Okay, so let's move on to graphing for inequalities. So yeah, remember, just a recap, if you have a variable, that would be sometimes true. Oh, actually, we can go back to this thing. Okay, so we have negative 3 times 2x minus 5, so number 12 is right here. And this is going to be negative 6x, so I'm distributing negative 3 to 2x, right? And this would be negative 6x plus 15, right? Because negative 3 times negative 5 is positive 15. And this is plus 1, which is greater than or equal to 4, right? So 15 plus 1 is going to be 16, right? Negative 6x, this is going to be greater than or equal to 4, and then you have minus 16, right? Does that make sense, guys? And then from there, as you can see, you have the negative sign on the left-hand side of the equation. Okay, so 4 minus 16 is going to be negative 12, right? Okay, so here's the thing that a lot of students tend to forget. If you're dividing one side, so for example, you have x here, you want it to isolate x, that means you have to get rid of the negative 6, right? By dividing both sides with negative 6. So if you divide both sides with negative 6, you need to remember to flip your equation symbol to its opposite side. So right now it's greater than or equal to, so it has to come out as x less than or equal to 2, right? So anytime you're dividing both sides of your equation with a negative number, whether it be 1 or whatever negative number, you need to make sure you flip, I guess, the direction of where your inequality sign is going. So right now it's greater than, now it's less than 2. Okay, so because we have to graph the solution, that means we're going to have a number line here, and 2 is right here because that's our x, right? Which is our interest. So in that case, this would be less than or equal to 2. So when you actually, this is my question for you. Are you going to include 2 or you're not including 2? So to answer that, because it's equal to, right? It's less than or equal to, this has to be included, right? So you're going to have something like this. So it has to be included, and because it's less than 2, you need to go in this direction, right? So everything here is going to be included, and that's 2, right? As one of your x's. Okay, so hopefully that was clear, but I think this should be sufficient enough. You can just draw it like this. So number line, you have 2, and then you can just include this going this direction to include that it's all before 2. Okay, so this number 13 here, you have negative 2x, right? And this is minus 18 plus 5, which is less than or equal to 3. So as you can see, let's see, negative 2x minus 18 plus 5 less than or equal to 3. So you only have one x here, which is on the left side. So you're going to have negative 2x, right? So negative 18 plus 5, right, would be negative 13. So you have to move negative 13 to the opposite side of the equation. So you're going to get positive 13, right? So 13, so this is negative 13. And then you have 3 here, right? So 13 plus 3 is going to be 16, right? So as a result, you need to divide both sides with negative 2. Again, a reminder, because you're dividing both sides with a negative number, you need to make sure you flip this inequality symbol, right? So in this case, this would be x greater than or equal to, and this is going to be negative 8. Okay, so when you draw the graph for this thing, you're going to have a number line here, and maybe let me just scroll up so you guys can see the previous one. So because this is greater than or equal to 8, that means you're going to have 8 right here, and that's going to be included, right? So anytime if it's included, that means you need to shade that little circle, because you're in math in general, that means you're passing through 8. That's part of it, right? So it's going to be greater than, so it's going to go in this direction, right? So it's anything that's after 8. So let's say they're asking you to graph an inequality which is just x greater than 8, right? So you're not going to include 8, so you're going to have this open hole right here, and then this is going all the way after 8. So it's 8 to infinity, right? Does that make sense? So that's the difference between with the equal sign and just the greater than symbol. Okay, hopefully that was clear. Just wanted to make sure for the people who are watching, am I making any sense? Please let me know. Cool. Okay, so let's get into the first two questions for inequalities. Okay, so we have a movie rental company offering 2 subscription plans, and then we have to figure out how many movies must you rent in a month for the first plan to cost less than the second plan. Okay, here's the thing with the keywords, right? So anytime you're dealing with math, but I think this applies to any subject that you're learning, if you're taking the test, just highlight things, right? Or just underline things. You have first plan to cost less than, so less than is the keyword, the second plan, right? So first of all, the first plan, you're saying it's $36 a month, and that's unlimited rentals, right? And then plan 2, it's $15 a month plus $1.50 per rental. So because you want the first plan to cost less than the second plan, so we can just say plan 1, and this is going to be less than, and it's not equal to, so make sure you have that. It's less than the second plan, which is plan 2. So you're going to formulate your equation or inequality for plan 1 and plan 2. So plan 1 is basically $36, right, per month. Sorry, a month, right? Yeah, which is the same thing. 36, and then you have plan 2, which is $15 a month, right? But they're saying that you have $1.50 per rental. So we can just denote per rental as every time you rent, right? So that's X. So the rental is X. So 15 plus 1.50, and this is times X, right? And then it says you need to find how many movies, right? So you're solving for X here essentially. So you're taking 15, moving that to the opposite side of the equation. So you're going to get 36 minus 15, and that's going to be equal to 21, right? 21, and then you have 1.50x, dividing both sides with 1.50. Okay, 21 divided by 1.50, that's equal to 14, right? So this is 14, and this is x, right? So that means you can just write this as x greater than 14. Therefore, you need to rent more than 14 movies, right? For the first plan to cost less than the second plan. Okay, there we go. So that's the answer. You need to rent more than 14 movies for the first plan to be cheaper. Okay, so far, so good. Okay, cool. For number 15, right, it says, a digital music service offers 2 subscription plans. How many songs must you download for the second plan to cost less than the first plan? Okay, so now they're changing things around. They're saying the second plan needs to cost less than the first plan, right? So because it's an inequality, I guess, sentence or sort of word problem, you need to make sure that you are able to translate this into a mathematical inequality, so English to math, right? So you have the second plan, so plan 2. This is less than the first plan, right? So the first plan is $9, so it's $9 plus a dollar per download, and then for plan 2 it's $25 plus 0.50 per download. So plan 1 is $9 plus a dollar per download. So we can just say download So the amount of times you're downloading would be X, so we can just say this is X, right? So 1 times X would be $1 per download. And this is going to be 25, right? And this is 0.50 plus 0.50 per download. Because they're the same download, so we can just say it's both X. So 25, right, minus 9 would be 16. So you're going to have 16 on this side. And then you have 0.50x, right, on the left-hand side. So you need to make sure that you move that. So you're going to have 1 minus 0.50, which is 0.50, right, x, and then divided by 0.50 for both sides. Okay, 0.50, there we go. So 16 divided by 0.5, that's 32. So this is 32, and this has to be less than x, right? So x greater than 32. So that's how you're going to write this. Okay, so because it's asking how many songs must you download, you need to download more than 32 songs, right? More than 32. Okay. So far, is that clear, everyone? Okay, so moving to this part. Yeah, okay, this is very similar to the one that we've been doing so far from the previous questions. And there we go. Okay, so here's the thing. This is going to be a mix of inequalities that we need to graph, and then you have keywords like and or. So you have or right here, right? So first of all, what's the difference between and or? So anytime you're graphing inequalities, if it says and, that means you need to find the overlap, right? Because it has to be both. So let's start with this 7 less than 2x on this side. So in order to solve for x, that means you would have to divide both sides with 2, right? So you get 7 over 2, which is less than x. Does that make sense? So in other words, we can say this is x greater than 7 over 2. Okay, just so you know, 7 divided by 2 is 3.5. So x needs to be greater than 3.5. On the other hand, you have 3x less than or equal to 18, right? So just so we have that, you need to divide both sides with 3. So you get x, and this is going to be less than or equal to 6, right? So 18 divided by 3 is 6. So as you can see, what we're comparing here is basically x greater than 3.5. So you need to draw 2 number lines, actually 3 number lines in total. So one for 3.5, and then the other one for x less than or equal to 6. Okay, let me just make my handwriting smaller just to fit everything. Okay, so x so we have x greater than 3.5. So that's in a number line. So you have 3.5, which is 7 over 2, right? And then let's just keep this as 7 over 2. So this 7 over 2 needs to be greater, right? And because we're not including this, that means it's going to be in a form of an open hole right there. And then you have less than or equal to 6. Okay, so 6, because this is 3.5, this is basically where 6 is, right? So 6 needs to be included, and then it's less than. Does that make sense, guys? So it's less than or equal to 6. So as you can see, the only overlap that we're seeing this is the overlap that we're seeing. It's basically from 3.5 until 6, right? So I'm just gonna shade this. Okay, I'm not sure if I made that worse, but you get the point, right? So it's basically from 3.5 and then you have 6. So when you're going to graph this inequality, your final answer should be I'm just trying to figure out where I'm going to place this. Okay, so we have here, I'm just going to place that here. So it has to be at 7 divided by 2, which is 3.5, and then it has to be at 6, right? So it's from here, right? This is included, and then you have this open because you're not including 3.5. So it's an overlap, right? Which is the yellow part. So this is your final answer. Okay. Right. Okay, moving on to number 17. Okay, so what I'm going to do, because we have limited spaces from 17 to 22, if it doesn't fit this page, I'm going to place them at the back page. So just so you're wondering. Okay, so for number 17, so I'll just continue solving like this. So we have 17. Okay. So we have 5 less than or equal to 3x minus 1. So we can just say this is 5 plus 1, which is 6. And then you have less than or equal to 3x, right? Dividing both sides with 3, you're going to get 2, right? So that means this is 2, and you're going to have essentially x greater than or equal to 2, right? So let's just draw that out. So 2 is right here. Number line. And greater than or equal to, that means 2 is included, right? So you're going all the way greater than 2. Does that make sense? And then you have 2x less than 12, right? So dividing both sides with 2, you're going to have x, and this is basically less than 6, right? So in that case, you're going to have 6 right here. And then this is going to be less than. That means you're going to have an open hole, and it's anything that is before 6, right? Dividing both sides with 2, so you have less than 6 right here. Okay, so remember what I said, because you're looking for and, right? That means you're going to just find the overlap, right? I think I drew this too close. Sorry, let me just move the 6. Okay, right here. Okay, can you see that? So there's sort of an overlap between 2 and 6 right there. Okay, can you guys see that? Okay, so that means when you're going to combine the two graphs, you're going to have 2 and 6, right? So here you have greater than, and then 6 is supposed to be less than. Okay, there we go. Sorry, this should not be included. So it should be a hole. There we go. So it's an open hole, right? So that's your inequality, and that's your graph. Cool. Okay, so for number 18, we have 7 plus k. So we have 7 plus k, which is greater than 15, right? And then on top of that, you have 8 plus k. This is less than 12, right? So as a result, you're going to see that you have k right here, and then you have 15 minus 7, which is 8, right? So as you can see, k is greater than or equal to 8. And then on the other hand, you have k, and this has to be less than. So 12 minus 8, which is equal to 4, right? So this has to be 4. So when you're trying to graph this, your 8 is right here. And then you have 4 somewhere here, right? So because this 4 has to be less than, that means you're not including 4 and it has to go all the way before 4. On the other hand, if you're looking at 8, you're including 8, right? So that should be shaded, and then that's after that. So anything that is after 8. Okay, as you can see, right? For number 18, yeah, we're looking at 7 plus k greater than or equal to 15, and you have 8 plus k, which is less than 12. So can you guys see an overlap within, I guess, within this equation? No, right? And first of all, why aren't we looking at the overlap? Because now the question is or, right? So in that case, you're not really supposed to be looking at an overlap. You're supposed to draw them together in one graph, right? So, hold on. So I'm going to move the 4 right here, and then this is your graph. Okay, so that's how you're going to draw number 18 in terms of the graph. For number 19, we have 7w plus 3 greater than 11, or 4w minus 1 less than negative 13. Okay, so since we don't have any more spaces, we're gonna move this. Copy. There we go. Okay, hopefully you guys can see number 19 and 20. Okay, so number 19, it's an or, right? So we're not supposed to do the overlap. So 7w plus 3, this is greater than 11. So we have 7w on one side, which is on the left side, and this is greater than 11 minus 3 is 7. So dividing both sides with 7, we get w is greater than 1, right? On the other hand, you have 4w minus 1, which is less than negative 13, right? So negative 13, and then you have negative 1 here, so that means this would become positive 1. So that would be negative 12, right? Dividing both sides with 4, right? Because you want to have just w. Dividing both sides with 4, you get w is less than negative 3, right? Okay, cool. So in this case, because it's an or, all you have to do is draw 1 and negative 3. So for w greater than 1, that's going to be right here. And then for w less than negative 3, that's going to be to the left, right? And they're not included. So this is your graph. And I know that there's going to be variations in terms of how your teacher draws this, so don't freak out about that. So all you have to do, you have negative 3 and then you have 1, right? And instead of drawing this thing, right, you can just say that this is going to be, this is not included, and then you can just shade this, right? Because I know some teachers, they do this. And then they have this open hole right here, and then they just shade it like this. It's the same thing. Okay, moving on to question 20. So we have 16, and this is less than 5x plus 1. So let's just go ahead and isolate x. So 16 minus 1 would be 15, and this is going to be less than 5x. Dividing both sides with 5, you get 3. On the other hand, you have 3x plus 9. Let's just write this better. X greater than 3. Okay, so you have 3x, and this is going to be less than, and this is 6 minus 9, which is going to be negative 3, right? So I'm moving 9 to the opposite side of the equation. I get negative 3, dividing both sides with 3. So here's the thing. So if you don't divide both sides with a negative number, even though you have a negative number right here, right? So a while ago, we were dividing this side and this side with a negative number. So in that case, we would have to flip the sign. However, in this situation, right, like right now, you don't need to flip this inequality sign because you're not dividing both sides with -3, right, or a negative number. So that means we're just keeping this less than symbol. So it's x less than -1. Does that make sense, guys? So right now, we're just graphing or drawing -1, and this is 3. So in that case, it's all going to be not, yeah, they're not included in this case. So they're not included, and this is greater than 3. So that's right here. And then you have less than -1, so that's going to be right here. So that's your graph. Okay, hopefully that makes sense. Okay, lastly, we have absolute values, right, to deal with. So this is 21 and 25. Okay, so anytime you're dealing with absolute values, okay, maybe we can start simple. So if you have an absolute value, which is, I guess, less than 2. Okay, this is just an example, me throwing numbers, but I want you to understand the concept of this. So if you have absolute value of less than 2, when you're trying to draw the graph, that means you should be identifying any numbers that are less than 2, right? So in that case, you're going to have two options. Not really two options, but you need two options. So you're going to have x, which is going to be less than 2. Let's start with a negative number first. So this would be greater than -2. And this would be x when it's less than 2. Does that make sense? So that's why this is really important, because you're identifying what are the numbers that are going to be less than 2, right? So in that case, you're going to have a -2, and then on the other hand, you're going to have a +2 right here. Okay, so basically that's the whole point. So when you're graphing this 2x minus 1, so maybe I can just write that here. Okay, so when you break the 2x minus 1 out, we should just get rid of the absolute value sign. Okay, there we go. So if you have 2x minus 1, that means this has to be greater than, right, the -5, right, which we have here. So this is 5, so we're looking at -5, and it has to be greater than -5. And then we're going to have an end, right, because we're looking at 2. So we have 2x minus 1, and this is going to be less than 5, right? So we're looking at this part. So in this case, if you have -5 and you have +5, you just need to solve for x, right? So 2x is greater than -4, right? Because it's -5 plus 1, which is -4 dividing both sides with 2. You're going to get -2 in that case. So x is equal to greater than, sorry, not equal to, x greater than -2, right? So on the other hand, let's say we're looking at this side right here. So you have 2x, and this is going to be less than, let's see, 6, right? Because it's 5 plus 1, which is 6, dividing both sides with 2, you're going to get x, which is less than 3, right? Does that make sense? And then because it's end, this is going to apply for every single absolute value you're looking at. So you're going to have -2, and then you have 3. Number line, there we go. Okay, so let's start looking at -2 for x greater than -2. So it has to be a whole, right? and then it's going to be greater than that. So that's going to the right of -2. On the other hand, you have x less than 3, and it's not included, so you're going to go towards the left, right? Because you're saying it's less than 3, right? As you can see, the overlap is going to be right here, right? So this overlap is simply just -2 and 3. That means you're going to have this until this. And that's your graph for this absolute value, 2x minus 1, and that's less than 5. And then we have 3x minus 4, and this is less than or equal to 8, right? So it's going to be the same thing. I mean, the way we set it up, right? So 3x minus 4, right? And this is less than or equal to 8. So as you can see, you're going to have 3x minus 4, and this is basically going to be greater than or equal to -8, right? And then you have 3x minus 4, so this is end, remember? And then this is basically 3x minus 4, and this is going to be less than or equal to 8. Okay, so again, we're going to solve for x. So you're going to have 3x on the left side greater than or equal to, and this one would be -8, right? Plus 4 is -4. Dividing both sides with 3, you're going to get -4 divided by 3. So this is x greater than or equal to -4 divided by 3 is, it's about -1.33. I just wanted to know where to graph this, and it's repeating, so no, actually, there we go. This is repeating. And then this 3x minus 4 is going to have (3x) on this side, and then you have less than or equal to 8 plus 4, which is 12, right? So in that case, dividing both sides with 3, you're going to have x, and this is going to be less than or equal to 4, right? Okay, there we go. So when you graph this, because it's end, right, you're going to have -4/3 here, and then you have 4 right here, because they're saying it's going to be less than or equal to 4, right? That means, okay. Yeah, let's start with the 4. So it says here less than or equal to 4, so that's included. And then you have this going to the left, right? Because it's less than, right? And then you have -4/3 on the other hand, which is going to be included as well. So this is going to the right. And as you can see, the overlap is right here. Maybe just, we can move this a little bit up. Okay, so this is where the overlap is. It's basically from -4/3 to 4, right? Okay, I meant -4/3 until 4, right? Okay. So that's where the overlap is. Therefore, your graph should look something like this. I'm just going to draw it here. So this